What's up? Are you ready for the second day of building the Oasis? So, our first day did not go particularly well. We did get a 3D thingy up running, and we did manage to get some model into the system, but like far from what I had hoped for. Also, the process needed a lot of guidance, and this is what we're going to look at today because that really frustrated me. So we got this promise from big tech that everything is going to be autonomous in 2026 and the singularity is here. So now the computer will just figure it out. So now the computer will just figure it all out. But that was not really what we saw. And today we're going to see if we can take just a small step closer to that. And so basically, I'm going to use one of the frameworks that I'm teaching at Compound Coders, which is the ACE framework, which is all about accurate prompting, then how you chain things, and then finally how you evaluate it. And for that, I've built out an MCP server, and we'll be using that to try to solve just a small problem. And then I think this will be the way we go forward. We solve some small problems, and then we eventually scale up and try to see if we can get it to do more and more autonomously. Okay, so let's get to it. This is here where we ended last time. There were some tests failing, and I think the first thing I will do is just do a new directory, experiments. And inside that one, we're just going to put Bevy here. Let's see. Excellent, that worked. Okay. And then this time we're going to use OneUp code, which is a small project that I'm building out on the side for, it's basically just another agent framework. Together with this agent framework, I'm building out this ACE MCP server. And this is what we'll try to do today. We'll try to use this to try to drive the process and be slightly more focused. And what I had in mind we should try today is that one of the things we want to be able to do inside of the Oasis is to talk to the MCPs. And for that, we will need to have some kind of natural way to talk with them. So we need a recording system. We need to have a way for it to figure out when to stop the recording. We will need to get that transcribed, then fed into an LLM, and then back again to the user. This seems like a small problem that's relatively complex. And so I'm wondering if we can get this done completely autonomously, or at least where we only give inputs to what we want and the agent just go ahead and implements it all. So I hope that makes sense for you. I think it's an important component of the system that is non-trivial and at least have a lot of steps involved in it. The other thing is also, I know that this can be done because I've seen other people doing this in some of their SaaS companies. And so the question is, how hard is it really to replicate this feature? Okay, so here we go. So how do I formulate this? That right, that as a voice interface you can talk to, it should and provide some response. So I think let's make this an interviewer. App should be an interviewer app. So user and that topic. Yeah, let's just see what it makes out of this. Right, so hopefully now it figures out that it needs to start defining a new project, and it should ask us some questions about what we are actually trying to do here. And so let's see, it starts planning the project. It's created a product. It now starts creating a feature. Let's see how this is going to go. In the meantime, let me just start another terminal. Okay. Okay, so what are the primary users for this voice interview app? Okay, so the primary users, so the primary users could be anybody, but the app should act as an, let's say, as a journalist. And we can always make it more general from here. That is interviewing the user on a specific topic. Let's just stick with that. And okay, does the user select the preferred topic? I think we will make it such that is specified in a text brief on startup. Can the user type in any topic they want to be interviewed about? Yes. Is there someone to configure custom interviews? Yes, this would be a great feature. Let's see, but in general, that AI should incorporate questions 3 and 4. I think, oh wait, 3. I think that's probably it. Okay, so one of the key ideas here is that we get the LLM to now interview us about what we're trying to do and gather a lot of context and arrange that into a ticketing system, which we'll see in just a bit. And so this is made in such a way that it's easy for the AI to navigate and put together context for subtasks that are being done. And so this is really about how do we construct these accurate prompts. And this seems to me like this would be one of the first things we really need if we want this to be completely autonomously building stuff. It still needs to get out what is it we're trying to build and how should it be done. Well, maybe not so much the how, but at least what should be done, and then it should figure it out itself, right? For the speech to text, listening to a user, should we use a specific service like, okay, one, please research this because I have absolutely no clue. For text to speech, oh wait, that was for speech to text. Let's just do. Um, should sound natural. Wait, so this is speech to text, text to speech. Oh, I'm mixing things up here. So this, the first one we are going to answer like this. So it should be, and two, this should be a voice that sounds natural and can be synthesized. Oh, synthesized. That seems wrong in real time. 3, do you have any preferences? Yeah, please research. Research. It is most important. It feels natural and not more than ease of use. Also, we need to implement the entire system in Rust. Okay. So I'm not sure whether it's actually going to ask us about language. I'm just throwing that in there because I want that in there. And we now asked it to research the options here, which it's now doing in order to answer our question. And yeah, I think that's probably it. Right. And so it was actually good that I mentioned Rust because now it's searching for Rust specific solutions. Let me record these ones. And so it starts recording the answers that we have given. Okay, next question. How should the interview flow work? How does the interviewer start? Yes, I think the AI should introduce itself and ask the first question. So how many questions should this should be configurable at start. Should there be a, is it 3? No, let's stick with a specific number of questions with no time limit. How does the interview end? I think it should just end with the AI saying thank you. I don't know what a journalist normally does. Should just say yeah, let's just say that. That last one is going to be a little bit of an interesting one because in my experience, when you don't limit the capabilities of or when you don't put any constraints on how AI is acting, what will happen is that it will just go down a tangent and then sometimes never recover because the original context is just getting completely lost. And I think that there is a real chance that will happen here. If it actually gets to implement this whole flow and it has that that there is no constraint on how it can follow up with questions, I think there is a real chance that it will forget that it has a fixed number of questions and that will be overridden by this other directive. But we will see. What should be captured and stored from the interview? Yeah, let's store the audio. Actually, yes. Okay, let's say full audio and transcript. And transcript. Store it in output. Um, That's a good question. I hadn't really thought about that. Like I just want to get something to work here. I don't really want to consider all the edge cases, but I guess if we're shipping something that's meant to be a production product, we should answer these questions. What should happen if something goes wrong during the interview? Um, let's put one. If the connection drops, a screen should appear and it should try to reestablish connection every 20 seconds. For microphone, show a screen saying please check your microphone with a, I don't know what it's called. I'm going to call it soundometer. It's probably not the right term. Add a pause and restart button. That seems sensible. Should the app try to recover save partial progress? Yeah, no, let's just not do that. Just exit gracefully for now. Oh, it really asks for a lot of questions here. Yeah, I would actually want this to be either a desktop application or a mobile application. Let's do it. Great. If this is a desktop application, if you use something, sorry, you frontend. And so what I'm asking it here is just to use you for frontend, because this means that we'll get Rust on the back end, Rust on the front end, and no JavaScript whatsoever. That seems sensible to me. And so the reason for that is that if we write everything in Rust, we'll get a lot of errors surfaced already at compile time. This means that we don't need to debug this at runtime, and this is the main reason for doing this. I know that LLMs work better, or they're faster at producing something that looks great with TypeScript. But what I've seen happening is that you get a first application very, very quickly, and then all of a sudden there is some weird little runtime error because it casts something to unknown somewhere in the whole process. And then after that, you're spending hours just debugging that. And that we really want to avoid. And in particular, if we can get rid of a lot of these errors at compile time, then let's do that. Okay, and while it does that, let's just go over here, and then what we will do is I'll just do Ace Explore, and this starts a little thing where we can see what tasks it's currently doing. So right now it's working out the use cases, and it has a tree here. So we're building out a product. We have here the content about what the product is about. And hopefully soon enough, it should start populating this with some requirements. What should the AI journalist personality be like? I think, yeah, okay, let's just go with that. Yes, all of your examples sound right. Go with that. It keeps on asking questions. Let me confirm the brief structure. What fields should you use? Configure topic, number of questions. Yeah. Yes, that sounds great. Sounds great. See what the music button does. If it does anything. Oh, I can't hear that because I actually don't have a headphone. Okay, cool. So I'm thinking user can fill out a setup form, blah, 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 start interview, AI. Hey, this sounds great. Let's just do this. Okay, cool. Does this capture? Yes, it does. Okay, so now it has gathered all the requirements of the project that we're building out, and the next thing it will start doing is creating requirements, and we'll see that very shortly over here. If we just refresh this one, okay, it's not create. Yeah, it starts to create something now, but they are still yellowish for some reason. Yeah. Okay. There you go. So it writes out the use cases now. And then once it's written out the use cases, it will start writing out the requirements. And so you can see here, we go to the use case and I just remove myself from here. It basically writes out who's the actors in the system, what are the preconditions, what is the main flow, what are the post conditions, alternative flows. And so we have a bunch of these different use cases. Basically explaining how the system is behaving in specific cases. And so as we go through this flow, we'll get more and more of these things. And it now creates the requirements for it as well. So again, if we just refresh this, I still need to work a bit on this UI. It's still very early stages. And you'll see now we have requirements. So for this first use case, we have 2 requirements. And this is the first requirement and the second requirement for this one. And so one of the really cool things here we're doing is that by doing it this way, we're getting a very, very hierarchical approach to how we're building out our software, right? So we start with this product, we then have a feature, and under the feature, we have a number of use cases. For each use case, we have a bunch of requirements. For each requirement, we have a validation criteria, we have some associated tasks, and now we can just take these ones one by one. And every time we pick one, it's super easy to construct the context that we need to work with, because what we're doing is we're taking that one, just asking, well, who's the parent? Who are the siblings of the parent? Who are the children of the parent? And we can create a very granular context for each of the things we want to do. And at the same time, we can create relations between the different nodes. So it's not just a tree, but it's actually more of a DAG in how it's structured. And that's what make this whole thing very, very powerful, right? So it's now created all of these things, and behind the scenes, these things are in staging. So that means that it's put into a state where it's not approved yet, and we can ask it to make modifications to our requirements here. And if we go back here and see, we can look at each of these requirements, go through them, and then basically ask, is this exactly what we had in mind? If it isn't, we could ask it to to revise it. But we're just going to promote this. Now, if you look at the whole process here, basically all we have done is we have set out what is it we're trying to do. We have let the AI interview us so we don't have to come up with all the mental work around how to formulate all of this. And then we have gotten the AI to arrange this nicely in a way that everything is chained in sorry, we start with this task, and then below that one, we have this list of items that we need to do. And for each of these ones, we can then very easily construct the context. And with the context, we can then derive new artifacts. So the next thing it's going to do is it's going to ask if it should do the architectural design. So we're going to tell it to continue with the architectural design. And it's thinking, and it's thinking, and it's thinking. Hopefully it will start on that a bit later. Now, the whole system here has a lot of different artifacts. So it has epics, it has products, it has the possibility of creating binaries, libraries, and all of this. And so it's up for the it's for the AI to basically arrange this in a way that makes sense to it from the questions that we have given, right? But we can basically go here and click on the product, and then we can see the to-do list for that product, which is the full tree. But we could also pick any subtask, and then you get this to-do list just to do that one subtask. And that's pretty much the key of it here. And then we can also see here with the small dots what we're currently working on. And it seems that it's gotten tired now because it doesn't do anything anymore. Ah, yeah, okay. Something happens. So the real question here is how much more autonomous is this going to feel compared to what we did on day one, where we made this 3D scene. I'm hoping that because we're arranging all of this context so nicely, that we will get to a point where we actually don't have to do much. And right now we are at a place where it feels pretty lightweight, right? We just need to write, please continue with the architectural designs, and then it starts doing things there. And let's have a look. I think it has done one now. Designs there. And so we can click that one. Again, the UI here needs to be improved a bit, but you see it writes out the architectural design with Tari application as front end. Oh, I really wish that it made a grabber here so we could make that bigger. But then it writes out how these two are communicating with each other through an IPC interface, sorry, and what the layer's responsibilities are and all of that. which means that it's super clear who's going to handle what. And eventually, when the context window is running out of, when the context window is running out as we're doing tasks, you can reconstruct all the relevant informations. Fuck, this was oh, and now I'm swearing. You can reconstruct all the relevant information just by looking at the graph that we've built out here. So that means that there's not going to be much confusion about whose responsibility is what, because all we need to do is help the AI locate that information, and hopefully it can figure that out by itself. And you see, we now have 4 design documents. If we go back to our tree, it has, let's see, where did it put these ones? It has the design documents down here. So for this requirement, it actually has 2 design documents. Or that was a design document that was placed the wrong place. Now it's been moved around. Okay. Right. So that was the one I see. This is jumping a bit around. We need to work a bit on that. This is still a very, very early stage UI that I've built here. This is why it feels a little bit unpolished, to say the least. But it does go to show the whole idea of building up all of these artifacts to make it super easy for the AI to reconstruct the right context for what it's trying to do. But I had not anticipated this would take so long. It would probably be great if I could make it so that it switches model in between these things. Right. And so what you will also notice is that right now, the only thing we've been doing so far for the past half an hour or so is planning. So we're just planning out the whole project, and I think we'll end up only doing the planning today, and then we will do the implementation tomorrow, because this is taking far too long. The other thing to say here is that we are creating all of these design documents while everything is still very, very condensed in terms of tokens, which means that a lot of the designs and the design boundaries can be kept within the context of the AI altogether. And this makes that when we are creating one design, that we can actually take into consideration the other design and make sure that those two are made in such a way that they make sense together. Okay, cool. And I think we are done with the design documents now. So all in all, 8 different designs explaining all the different interfaces we're going to have. And I just remove myself from, see, it even has mock-up of what the UI looks like in the most beautiful ASCII format. I start to regret that we didn't do this as an ASCII application. That would have been awesome. I really like this design. And then it has, oh, there's something I forgot to tell it here. It should be using Tailwind. Oh well, you can't win every time. You'll just have to do that in some follow-up work. And then it has some mock components here of what things could look like. Again, beautiful ASCII drawings. Love it. Okay, that seems pretty comprehensive. And we go back to our tree. We see all of these documents being done. So, okay, would you like me to proceed with implementation? I think we've shown here how the ACE framework works in a very, very short way, right? So I've shown you how the AI interviews me to get a very accurate context of what I'm trying to do. Then using that, we're generating a lot of artifacts that we're chaining the right way to make sure that we have a comprehensive overview of what we're trying to do and make it so that we easily can reconstruct context as we go forward. And then finally, one of the things that we will do next is we'll do the implementation. And then finally, after that, for each of the tasks, we can actually go in and do an evaluation and say, hey, now you have implemented this task. Would you now evaluate that it fits against the requirements and the success criteria we wrote down, which is super powerful because this is a way we can make sure that the AI is basically, what is it called in English? It is monitoring itself and self-correcting, right? And this is exactly what we want. We want to get to that point where it has this big objective that it's trying to achieve, and it figures out how to fix things on its own. If you think some of this is interesting and you want to learn more about it, I'm right now building out a course on how to do coding this way, and in particular, how you make sure that you can do large-scale projects in a way that is sound and easy to maintain as you grow the size of the project, which is why we have taken on this very, very big and ambitious project. And at the same time, we start small so we can get a good feeling with how are we going to solve this problem and how can we really scale it. And so by being part of these live events, you get to see firsthand some of the things that I'm experimenting with and some of the software that you can get access to inside of Compound Coders. So I hope you enjoyed it, and stay tuned for more.